Hi friends, welcome you all to Think Max. We are in class 11 Max chapter 1 sets. In this session we are going to discuss about the introduction to exercise 1.2. That is, what are the concepts involved in exercise 1.2. So here first one, empty set. What do you mean by empty set? A set which does not contain any element is called the empty set. So in the set there will not be any elements. So there are other two names for empty set, that is null set or void set. So empty set will also be called as null set or void set. So it is denoted by the symbol phi. So that is nothing but put on circle and a standing line. So this is the symbol for null sets. There is empty set. So there will not be any elements in the set. It is denoted by phi. So we can write A equal to phi. So if this is so, there will not be any elements in the set. Or we can also write it as A is equal to, write the curly bracket and close the curly bracket. There will not be any elements. So no elements in this set. So A is equal to null set or void set or empty set. So there are some examples. First one, A equal to set of all x such that x is an even prime number greater than 2. So it is a prime number and that prime number is even. So what are the things? And that prime number should be greater than 2. So prime number means, what do you mean by prime number? It should be divisible by 1 and itself. So the first prime number is 2. So 2 is divisible by 1 and itself. So this is the only prime number which is even. So other prime numbers are not even. So 2 is the only prime number which is divisible by 1 and itself. Here it is greater than 2. So greater than 2 means this 2 will not be included. 2 is the only even prime number. So this prime number will not be included in this set because they need an even prime number greater than 2. So there is no other prime number greater than 2 which is prime. Okay. So no even prime number. So only even prime number is 2. So here it is greater than 2. So we cannot have any elements in this set. So the solution is A is equal to phi. That is, it is empty. Or we can write A is equal to null set. So open the curly bracket and close the, leave some space and close the curly bracket. So there is no elements in this set. Next, in the same way, set of triangles with 4 sides. Here also there is no element because triangle will have only 3 sides. So we don't have any triangles with 4 sides. So this is a null set. Next one. B is equal to set of all x such that x square equal to 4 and x should be odd. So we have to find out this solution. In this solution, the value of x should be odd. Let us check it. So x square equal to 4. To find x, I am going to take square root on both sides. So square root of x square, the square root and power 2 gets cancelled. So we will get x. And square root of 4 is plus or minus 2. So it is 2 square. So it is x is equal to 2. So x is equal to 2 is the only solution. So it is even. We don't have x as odd. So b is equal to null set. We can write it as b is equal to null set. Just open the curly bracket and close the curly bracket. Or we can write b is equal to phi. That means there is no element in the set. B is empty set. Okay, children? So moving on to the next topic about finite and infinite sets. So as the name suggests, finite means we can count the elements in the set. A set which is empty, so that is 0. How many elements are there? 0. Or consists of a countable number of elements is called finite set. So we can count how many elements are there. Then those sets are called finite set. Next one, infinite set. A set which consists of an uncountable number of elements. That is, we cannot count. We cannot say 20 elements are there, 30 elements are there. So it is uncountable. If we are not able to count the elements, then it is called infinite set. So examples. The set of the days of the week. Yes, we can count the days of the week. So how many days are there? We can say 7 days. So this is finite set. We are able to count the elements in the set. So it is a finite set. Next, the set of points on a line. So if we draw a line, we can mark so many points. Okay, we can mark so many points. So this is infinite set. Next, A is equal to set of all 2, 4, 6, 8 up to 100. So here A is nothing but set of even numbers less than or equal to 100. So we can count it. So it is from 2 to 100. The even numbers from 2 to 100. We can count those even numbers. We can write all the numbers from 2 to 100 and count it. So it is a finite set. Next one, B equal to set of all x. X is a natural number. So what is that B? Natural number means counting numbers. Counting numbers start from 1, 2, 3. It goes on. Okay. So there is no last number. So it is not a finite set. So we cannot say there are 10 numbers or 20 numbers. So it goes on till infinity. So it is an infinite set. So this is infinite set. Next one, C is equal to set of all x. X is the solution of the equation x square minus 16. So how many solutions are there? If we take x square minus 16 equal to 0, we can write x square equal to minus 16 will become plus 16. So x square equal to 16 is nothing but 4 square. So taking square root on both sides, root and power 2 gets cancelled. So x will be equal to 4 or minus 4. So we can take plus or minus 4. So we can say only x is equal to 4 and x is equal to minus 4. So C is equal to minus 4 comma 4. So we can count this. There are two elements in this set. So then this is finite set. So if we are able to count, then it is finite. If we are not able to count, we cannot count the number of natural numbers and we cannot count the number of points in a line. So those sets are all infinite set. I hope you can understand what is finite and infinite set. So we move on to the next topic, equal sets. As the name suggests, we can take two sets. Two sets A and B are said to be equal if they have equal and same elements. Counts should be equal and the elements will also should be same. Okay, count should be equal and the elements should be same. Then the sets are said to be equal. So empty sets are equal to each other. So and we write it as A equal to B. Okay. So they are equal to each other. That is A will be equal to B or B will be equal to A. So for example, we took two sets. A is equal to 1, 2, 3, 4. What is B? B is equal to 3, 1, 4, 2. Let us check this. Yes, 1 it is here. 2 it is present in B. 3 it is present in B. 4 it is present in B. So they have equal number of elements. So they have 4 elements. Both A and B have 4 elements and the same elements. Here 1, 2, 3, 4 is here. 3, 1, 4. Order can be changed, but the elements should be same. Then we can say A equal to B. Next one, capital P is equal to set of all x such that x is the set of prime numbers less than 6. And what is Q? Q is equal to set of all x such that X is the set of prime factors of 30. So let us check what is P. P is equal to set of prime numbers. What are the prime numbers less than 6? So it is 2, 3 and 5. So these are the prime numbers less than 6. Now we have to find out the factors of 30. So how do you factorize 30? So it is 2 into 15 and 3 into 5. So what are the factors? 2, 3, 5. So now if you check, there are 3 elements in P and Q. So 2 is present in both P and Q. 3 is present in both P and Q. And 5 is present in both P and Q. So we can say P is equal to Q. That is, two sets P and Q are equal sets. Okay. Now next one, next example is written that X is equal to M, A, T, H, S. What is Y? A, M, C, S, H. So how many elements are in X? There are 5 elements. In Y also we have 5 elements. Now let us check whether they are same or not. Here M is present and M is present in Y. A is present in X. A is present in Y. T is present in X but it is not present. Okay. H is present in X. It is also present in Y. S is present in X. It is also present in Y. Now only thing, T is not present in Y and C is not present in X. So there are some differences. So then we can say capital X is not equal to capital Y. Okay. So let us move on to the next topic for the exercise 1.2. It is the last topic for exercise 1.2. Singleton set. So as the name suggests, single means only one. The set which have exactly one element is called singleton set. So in each set we will have only one element. So let us take A is equal to set of all x such that x is the set of even prime number. So the only even prime number is 2. So A is equal to, start with the curly bracket, the only even prime number is 2. So this is the singleton set because only one element is present here. In the same way, B is equal to set of all x such that x is neither prime nor composite. So prime means it should be divisible by 1 and itself. The number should be divisible only by 1 and itself. So if we take 5, 5 is divisible by 1 and 5 is divisible by 5. Composite, what do you mean by composite number? It is nothing but it should be divisible by 1, itself and other numbers. So if we take 4, 4 is divisible by 1, 4 is divisible by 4 and also other number 4 is divisible by 2. So this 4 is composite. So which number is neither prime nor composite? So if we take 1, the 1 is divisible by 1 and it itself there are two numbers which should be divisible for prime number 1 and itself. So if we take the number 1, it doesn't undergo this condition. In the same way for composite, it should undergo 1, itself and other numbers. So it is divisible by 1, not itself and other numbers. So the only number which is neither prime nor composite is 1. So there is only one element in this set. So it is called singleton set. Okay. So with this, all the concepts involved in exercise 1.2 is completed. So in the next video, we will deal examples related to this concept and exercise related to this concept. Okay, children, I hope you can follow my videos. If you are able to follow, just show your support by subscribing to ThinkMax and also share among your friends and hit the bell button so that you get the notification whenever I upload my videos. Thank you.